KW Physics. I'm Mr. McConnelly. Today we're going to talk about the idea of momentum. And momentum is often confused with the idea of inertia. Now you did inertia earlier in the year, and inertia and momentum are not the same thing. Momentum depends on two things. Momentum is based on the mass and the velocity of the object you're talking about. In fact, the equation is very easy for momentum. Momentum is mass times velocity. And that's the way it appears in the physics reference table. And the funny thing is that the rho, the Greek letter rho, is the letter that stands for momentum. And to a lot of people who are like, well, why didn't you use an M? Because M was used for so many other things. So rho means momentum. And if you're talking about the units, obviously mass is in kilograms. Velocity is in meters per second. So momentum is a kilogram meter per second. And there's no abbreviating that, or we don't abbreviate it, that's what the units are. It's a little bit awkward, but that's your momentum unit. So let's talk more about what it means though. If you back up previous knowledge to what inertia meant, what was inertia based on? Completely based on?
Mass.
It's based on the mass. Inertia was only based on mass. And so when I asked you questions about inertia, I basically gave you choices, and if I was asking for the most inertia, you'd pick the one with the most mass. Done deal. See, Robert? But when we're talking about momentum, we're not just talking about mass, we're also putting in the velocity. So if the velocity gets bigger, or the mass gets bigger, you're changing your momentum. So let me pose this question to kind of get the idea where we're going here. Are you more afraid of someone shooting you with a BB gun, not a gun that's going to kill you, a BB gun that's going to hit you, or a paintball gun if you want to think of it that way? Are you more afraid of a paintball or BB gun, or are you more afraid of getting hit by a semi-truck? And the answer is obvious. You're very afraid of the semi-truck because there's so much mass. And if they're both going the same speed, then you're really afraid of the truck, okay? Because that truck is hauling, and you know that it has so much more mass. You're just going like, you're scared of it. Okay, so the idea of momentum has a lot to do with inertia, but they're slightly different. And I'm going to refer to the Physics Regents June 2003. There's a good question, kind of gets at the difference. Number 15 says, which person has the greatest inertia? But what they do in this problem is they try to trick you. They say, how about a 90-kilogram man walking at 2 meters per second? The alarm should go off in your head, because if they were asking about inertia, does it matter how fast the guy's walking? No. But all the answers, they say a 70-kilogram long-distance runner traveling at 5 meters per second, a 50-kilogram girl sprinting at 10 meters per second. What they're trying to get you confused with, the idea of momentum, because momentum depends on both, inertia only depends on mass. So that's my warning for that. And we could plug in some numbers. I could say my mass is 95 kilograms and I'm running at 10 meters per second. And you would just do 95 kg, 10 meters per second. You can do it in your head, 950 kilogram meters per second. That would be the momentum if I were running at 10 meters per second. It's that easy. But we got to take it one step further to finish this off. Ultimately, usually when you have momentum, there's also a collision involved. So you have some momentum, you have an object moving along, and then it hits something else. And when it hits something else, you're applying a force to that other object. So what ends up happening is that momentum ends up equaling this idea called impulse. And impulse is upon collision. So, impulse, which is actually given the letter J, I know that's bothersome to a lot of people, but it's kind of like momentum given the letter rho. Okay, impulse is J. I don't know why. But impulse is the force times the time. So that's another reference table equation. The impulse is the force times how long that force is applied for. So when something runs into something else, smack. It's how hard, force in newtons, times the amount of time that the two objects were in contact for. That's the impulse. But what's cool is that you can set it equal to the momentum. So you see where we might be going here, is that now you can set momentum equal to the impulse or any combination thereof. Like if you know the mass and velocity and you want to know the impulse, you can set mv equal to j, for instance. And you can start combining this in different ways for whatever the scenario is. So for today, that's physics.